Good morning students. So let's continue with testing techniques. So in the last lecture we have seen one of the method, that is boundary value analysis, which belongs to a category black box and which is a dynamic type testing. Now today we are going to discuss equivalence class partitioning. So what does equivalence class partitioning means? It says that whenever the input domain is very large and it is practically impossible to check for all possible inputs, we divide our input into equivalence classes. Equivalence classes means the value which belongs to a particular class has a similar behavior, right? So how do we proceed with this it is a two-step process. First we have to identify the equivalence classes from the problem statement, and then we need to design the test cases. What are the guidelines that are used to divide this into equivalence classes? There are two specific guidelines. If the input value is given in the form of range of values, in that case we'll have one valid class and two invalid classes. That is, whatever is a given range will be a valid one. Less than that range is an invalid. Greater than that range will be invalid. So one valid and two invalid classes. While if we have input in the form of discrete numbers, so in that case we'll have two classes, one valid and one invalid. Valid class for the given discrete value, while all the other values except the given value belongs to invalid case, right? So we'll be having two classes in this case. So let's see an example here. Suppose we need to check whether user inputs the number in the range 0 to 5000 or not, right? So in this class, first of all, we have to design the equivalence classes, right? So there will be three equivalence classes. One class will have all the negative values, that is less than 0. Another class will have all the values between 0 to 5000, and the third class will have all the values greater than 5000. So one valid and two invalid classes. So how the test case will be designed using this method? We will take one value from each class. That will constitute one test case. So similarly, we can take 4 or 5 or 10 test cases, which is called as test suite. We check our system with all those test cases to get an optimum result. So let's see, the test case design will be one negative value, one in the given range and one greater than range. So this is one test case, and when you apply this test case to your code or your system, right, it is going to check all three behavior at one time, right? So there is a least possibility that we skip one or the other behavior. Coming up to second example, a program reads three numbers A, B and C with a range 1 and 50 and prints the largest number. Now we are supposed to design test case for this program using equivalence class partitioning, right? So understand, we have three numbers, range is same 1 and 50, and we have to print the largest number. Now what is the solution to this? First of all, we'll make the equivalence classes. So in this case we will make the class, say for A, B, C it's given. So the first class that we are going to make here is for A, and it has the value between 1 and 50. So this is a valid class where value of A is in the range 1 and 50. I2 is a class for B. Again it is a valid class. The value ranges from 1 to 50. And again for C we have a valid class I3 and the range is from 1 to 50. So these three are your valid classes. Now we'll talk about invalid classes. So we'll have fourth class where A will be less than 1. That is, since the range given is 1 and 50, so we'll take less than 1 values, and in another case we'll take greater than 50 values for A. Similarly for B, less than 1, greater than 50. Again for C, less than 1, greater than 50. So altogether we'll have 9 classes in which we had 3 valid classes and 6 invalid classes. Now the test cases can be designed from the above derived classes, taking one test case from each class such that the test case covers maximum valid input classes and separate test case for each invalid class. So this is the criteria that we need to follow. Now see how the test cases are being designed. So we give test case ID, all the three inputs are taken, what is the expected result and which class is being considered while designing these test cases. So let's assume we have taken all 3 values A, B and C in the given range, that is valid class. So valid class were 1, 2 and 3. So we are giving input which is going to satisfy these 3 inputs, right? So in this case, what should be the expected result? We were supposed to print the largest of the 3 numbers. The largest will be C. So it is going to print C is greatest. Now other inputs will be for the invalid classes. So definitely we know expected result will be invalid input. But how to design it? Let's assume in the first case we are taking A as 0 while B and C in the given range. So it is less than. So it is an invalid and it is going to satisfy 4th test case. Then in next one, 3rd test case ID, we are taking A value greater than 50, that is 51 in this case, right? So it will give expected result as invalid and it is satisfying the 5th one. Similarly, you can see now here B is 0 and 53 in the 4th and 5th one, while in 6th and 7th test case we have C as 0 and 51. So we'll get invalid and all the test classes that we have identified are being mentioned here, all the 9 test cases, right? So this is what one example is. Hope this is clear to you all. Let's talk about one more example. A program determines the next date of the calendar. Its input is entered in the form of DD, MM, YY, that is a date, and the range given is month is between 1 and 12, date range between 1 and 31, and year ranges between 900 and 2025. Its output would be the next date or an error message, that is invalid date. Now we are supposed to design the test case using equivalence class partitioning method. So first of all, what will be our first task? We have to identify our classes, right? Valid as well as invalid, both. So we'll have one class for month. This is a valid class. For date, it is a valid class. Year, a valid class. Other than this, we'll have invalid classes for all the 3. This is month will be less than 1, month will be greater than 12 is an invalid. For date, less than 1, greater than 31. For year, less than 1900 and greater than 2025. So ultimately these are the 9 classes, valid as well as invalid, which are being identified here. The test cases can be designed from the above derived classes, taking one test case from each class, right? So how? See, month we have taken, see nominal range will be taking or will be taking in the given range, that is 5, 20 and 1996. So what should be the expected result? Next date. So you have taken as 20 May 1996. So it will print 21st May 1996, that is next date. This is 20, so 21st will be printed, and it is going to cover all the 3 valid classes I1, I2 and I3. Rest you are going to give invalid ranges, say for month 0 and 13, less than 1, greater than 12. In 4th and 5th, date is beyond the range, while in 6th and 7th, year is beyond the range, and the expected result will be invalid input. So this is what the classes it has covered. So hope this is clear. Thank you for today.